And it's made up of two shapes. I've got this rectangle right here, and I've got this triangle up here. Okay. So one thing, first of all, is to find the area of that whole thing. We just need to find the area of the rectangle and the triangle and add them together, because those two shapes are being put together. Now the rectangle, hopefully you can see, we have all the information we need to find the area of that rectangle, because I've got the length, or I've got the base, I've got the height, or if you want to use the terminology length and width, same thing. And so we can find the area of that rectangle already. The problem is if you look at the triangle up here, we don't have enough information about it, at least not yet, because to find the area of the triangle, we have to have the base and the height, which we don't have both of those pieces. Now, there's two ways to look at this triangle, and I'll work through one way, but I'll quickly mention the other way. So one way, and then we'll work through it the other way. So one option is to look at this triangle the way it is. So you've got this shape right here. We know the base is 26, but we don't know what the height is. Okay. Fortunately, because this side and this side are the same, that means, going back to stuff we talked about in chapter 5, that this has to be 13 and 13. Okay. And then you can use, we've got the altitude drawn into a right triangle. You can use the geometric mean stuff from section 7.4. Nope, sorry, 7.3 is what it was in. Sorry, I just had to think about that for a moment. So section 7.3. So if you want to look back and do it that way, you can do it that way. The other option, which is the way that I'm going to go ahead and do it on here, is instead of leaving the triangle the way it is in the picture, I'm going to rotate it just a little bit. So I'm going to take this picture and I'm going to rotate it sideways, so that instead of my hypotenuse, which is 26, being over here, being my base, now my base is this. Okay, and that's x, and that's x. Now, on the one hand, this one is this one we'll need to figure out both the base and the height, as opposed to looking at it the other way where we just had to figure out the height. But on the flip side, we actually we only need to find one of them, because the way that I rotated it makes the base and the height the same thing. Okay, and so that's why I'm going to go ahead and do it this way, because then I can solve for the base and the height. They end up being the same thing. Okay, so now there's a couple ways we can go about doing this to try and find that x. Your first thought is probably using Pythagorean theorem. So I'm going to go ahead and show that way, but then I'll quickly explain how you could do it in another way. All right, so if we set this up using Pythagorean theorem, it's going to be x squared plus x squared equals 26. X squared plus x squared is going to be 2x squared. And then 26 squared is 676, and you can get that just by typing it into your calculator. All right, now from here, what you can do is we want to try and solve for x. So we're going to divide by 2. And that's going to give you 338. Sorry, I'll write that over here. So 338 is going to equal your x squared. And then to figure out x, you would just have to square root both sides. And that's how we get that right there. Okay, so x is equal to the square root of 338. And now it's up to you. For my work, I'm just going to leave it as the square root of 338. You can, if you want to, write it as a decimal. You might think it's easier to write it as a decimal so you don't have to deal with it as a square root, and that's fine. I'm going to leave it as the square root because actually, when we actually try and find the area, you'll see that it ends up working out nicely to leave it as the square root. But again, either way it works. If you turn into a decimal, you're going to end up having a rounded answer. So it's just up to you as far as if that's what you really want. Okay, really quickly, I'm just going to show you another option as to how you could have found that. I'm going to redraw my picture just a little bit lower. I forgot that I had some text going over there. Okay, so there is the picture. So some of you may have recognized this as a 45-45-90 triangle. Okay. And if that's the case, then you could use the rules that we had for that, which says that if you're given the hypotenuse, the legs are just your hypotenuse times the square root of 2 over 2, which ends up making this equal to 13 square root of 2. Okay. If you were to take this answer over here, and go back to algebra where you did your factor tree, break it all down, you would end up with 2 being a factor and then 13 and 13, so you have a pair of 13s, take it out. I don't think you guys do a lot with that in Algebra 2, or in Algebra 1. You'll do more of it in Algebra 2, so that's why I don't want to worry about that too much, and it's not going to end up mixing up our answer. So either way works. All right, so now what we need to do is we need to actually find the area. Okay, so we have the rectangle, which is going to be 26 times 18. And then we need to add to that the area of our triangle, which is going to be half of the square root of 338 times the square root of 338. Okay, or 13 square root of 2 times 13 square root of 2, if that's what you chose to use, that's fine. Now, this is why I went ahead and left it as a square root, because when you times a square root times by itself, if you type it into your calculator, that's fine. It's the same thing as saying the square root of 338 squared. And when you square square root, it goes away. So, this right here ends up just being half of 338. If you take the square root of 338 times the square root of 338, you will get just 338. And then you can type 26 times 18 plus half of 338 into your calculator, and you get 637 feet squared. So we now know that the side of this barn is, what was it, 637 feet squared. Now we just need to figure out how much paint will be required to do that. Okay, and again, this is another one where there's a couple ways that you can do it to actually figure it out, just depending on your thought process. We know that 350 feet or square feet is going to be covered by 1 can. So what you can do, so the simplest thing you can do is just take 637 divided by 350, and that will tell you the number of cans you will need. Okay, sometimes if you're not sure if you're supposed to, again, sometimes you don't know if you're supposed to multiply or divide. So what you can do, I'll just kind of put this up real quick. What you could do, we talked about way back in chapter 1, I think it was the idea of unit analysis. And I know you guys do this in chemistry as well. So I'll just kind of put that up really quickly. It's the idea of that we know that this is our area. And 1 gallon is equivalent to 350 square feet. And you put the square feet on the bottom because you want the feet squared and the feet squared to cancel out. And then you can put this over 1, 637 times 1, and then 1 times 350. You get 637 over 350. Divide them, and that leaves you with your number of gallons. So again, this way is a little bit easier, but this way sometimes might make more sense to you. So again, either way is fine, whichever way you think about it. But we'll need about 1.8 gallons. Now, you can't go to Ace or Menards and buy 1.8 gallons. So how many gallons would you actually have to buy? The answer is 2. 2 gallons of paint. All right, so that's it for the types of problems. We'll just do a couple more extra practice problems. So if you're good to go, you can stop. You can try the rest of the examples on your own and then just check yourself, or you can continue watching for a little bit of extra practice. All right, so here you want to find the perimeter and area of this polygon. It is a triangle, so perimeter, you need to add up all the sides. Remember that the sides are just the outside, so that height in there is not a side of the triangle. Triangle has 3 sides, so you should only use 3 sides. 17 plus 10 plus 21. 17 plus 10 is 27. 27 plus 21 is 48. And it's perimeter, so it's going to be units, because we don't actually know the units. And then for area, area is half of base times height. The base is 21. The height is 8. And then multiply that, and you will get 84 units squared. Okay. Remember that perimeter is just units, area is units squared. All right, this shape is a parallelogram. So perimeter, we need to add up all the sides, but we're only given 2 of them. Fortunately, though, we've learned that in a parallelogram, opposite sides are the same. So that's 20 plus 30 plus 20 plus 30. That's 50 right there. That's 50 right there. So that equals 100 units. And then the area of a perimeter is just base times height. 30 is your base. Your height is not the 20, it is the 17. And if you type 30 times 17 into your calculator, you get 510. And that's units squared. All right, I think this is the last one. So parallelogram has an area of 153 square inches and a height of 17 inches. What is the length of the base? So if it helps you to draw a picture, just draw an arbitrary parallelogram. I'm sorry, that one's not the greatest. The height is 17. The base, we don't know. We know for a parallelogram the area is base times height. I don't know why it keeps drawing those lines in there. I apologize for that. So the area is 153. The base we don't know. The height is 17. So when you write it out like this, you can see that all we have to do is divide by the 17 to figure out that our base is 9 inches. All right, guys, that's the homework. Quiz will be up on PowerSchool. And let me know if you have any questions.